Okay, guys, in the last lesson, we were looking at comets, and I want to continue with that today. And we're going to move on and look at meteors, meteorites, and meteoroids. So there's three different kind of classifications there that we want to study today. And don't forget, we want to look at asteroids as well. And once we've done all of that, then we will try to see how they fit into the big picture. So, in the previous lesson, this is what we covered. We said a comet is a celestial body, so it's something found outside of our atmosphere. It is made of dust, rock, and ice, okay, and it glows, producing a tail when orbiting a star. Now, what we is not mentioned in that definition is that it really glows when it passes really close to the star, okay? You do need to know a few kind of characteristics of a comet as well. So, what could we say about the comets in our solar system? They have a highly elliptical orbit. So, that basically means you have your stretched out circle. Okay. We know that most of the comets in our solar system are found in Kuiper's belt, okay, which is kind of quite far out in the solar system near the outer planets. And another thing then is that the comet itself has a 10 atmosphere, remember, because the ice, when it comes near the sun, it changes directly from ice into a gas. And that's kind of an unusual change of state of matter, which is called sublimation. And that gas is the atmosphere that makes up the outside part of the comet, which glows when the sunlight passes through it. Okay, so that's what you want to know there about comets. And remember, we saw this video here from the European Space Agency about how to make a comet, which is a really good resource if you want to look it up again. So, where do we go next? Meteors. So, what are they? What we can say about meteors is that they are rocky objects that enter Earth's atmosphere. So when we say there is a meteor strike, what we're saying there is that there's a rocky object out in space that is entering Earth's atmosphere. There is two distinctions here I want you to remember, okay? A meteoroid, which is a rock smaller than an asteroid, usually it is bigger than a pebble, is floating about in space. Okay, so these are objects that are smaller than asteroids, but most of them are only pebble-sized objects. You've got a meteorite then, which is a small rocky object that has made it through the Earth's atmosphere. What I think is interesting about all of this is that the Earth's atmosphere protects us from meteors, because what happens actually is when the moment a meteor enters the Earth's atmosphere, remember at that stage it's going to be called a meteorite. When the meteorite goes through the Earth's atmosphere, it actually burns up. So this is why we see the flames. Most of the time, that will burn up completely. It will vaporize, so it'll turn into a gas, and we never actually see the meteorite itself because it has burned up high in the atmosphere. When you compare that, however, I suppose if we take into account all the different types of meteorites that do get through our atmosphere, um, like if they're pebble size, they're probably going to burn up. But if they're very big, they might get through. Okay, and this is where you might have a meteorite strike, where the meteorite hits the Earth, and we have a big crash. Okay, so crucially, when we talk about meteors, they're rocky objects, but they are smaller than asteroids. Okay, so if you want to read that in your own time, there again the explanation is given there for you why we don't have to worry too much about meteorites or meteors too often, because really the Earth's atmosphere being so thick burns them up. Right, so moving on, what are asteroids? So the one kind of area of the solar system I do want you to remember is what we call the asteroid belt. Okay, and that is a section of our solar system located between Mars, well, after Mars, and So we have my very evil mother just. Okay, so between Mars and Jupiter. You can see that here actually on the diagram. This is the asteroid belt. And what we know about the asteroid belt is that this is where most of the asteroids in our solar system are actually found. So just our solar system now, we're not talking about other solar systems. And when we're talking about asteroids, we're talking about something that's bigger than a meteor. Okay, so they're very large objects. Some of them are not too far off being the size of moons or even planets in some cases. So they're massive objects. But they are, what are they really? They are generally smaller than a planet and they orbit a star. Okay, they're basically just a big rock, that massive rock that is smaller than a planet but orbits a star. Okay, so there's your definition there for an asteroid. We believe asteroids have a relationship here with the extinction here of the dinosaurs in the past. Okay, that there was a collision, and this is observable on the planet because we see massive craters, and I suppose it's called, the area of this is called geology, where you study rocks. And if you look at the surface of the planet, you can see it, you can actually learn an awful lot about its geological history, and we can identify where impacts have occurred in the past. And it's believed that here that this was the reason that the dinosaurs, one of the reasons that the dinosaurs went extinct, because it caused a huge increase in volcanic activity, and the dinosaurs simply couldn't cope. Good for us, though, of course, because when the dinosaurs went extinct, that allowed mammals to thrive and survive, and we ourselves are mammals. Right, so how do we know the difference between an asteroid and a planet? And the main reason we know, I mean, if you think about it, like Mercury, for example, it's a gray planet, it's spherical, it doesn't look altogether too different to an asteroid, but for the fact that it's spherical. Okay, so what we know about asteroids is that they are irregular objects found in space, and they orbit a star. So they tend to be irregular shapes. So, like if you just pick up any rock off the ground, it's probably going to be a kind of any kind of shape, and that's the same for asteroids. They are all types of shapes. So, how are we protected on Earth? What unique conditions on Earth protect us? Okay, so if you have a think about this for a second, you probably have an answer already for one of them. Okay, so life is protected on Earth because of our thick atmosphere, which of course is going to burn up through the process of friction. By the way, it's going to burn up um, celestial bodies like oh no, not asteroids really, they're too big, but it's going to burn up things like meteors once they enter Earth's atmosphere, in other words, meteorites. So it prevents those collisions, which could be catastrophic. Okay, so it burns them up through the process of friction. By the way, friction, guys, that is basically, if you can think of friction, rub your two hands together, that's friction. So friction generates heat, and it's the high temperatures of when the friction of the atmosphere comes across these meteors that burns them up. So that's one way that we are protected. If it's a second thing that how our atmosphere is protecting us, and I suppose maintaining life on our planet, is because we are. And if I go, maybe I'll go through here step by step. The first thing here provides oxygen that we breathe. Well, it's kind of self-sustaining because we have plants which photosynthesize, which produce oxygen as a waste gas, which we then breathe ourselves, and we recycle it. Then it's going to be recycled because we breathe out carbon dioxide that's taken in by plants again, and then we will they produce oxygen again and we breathe it in again. So it's kind of this never ending cycle. The second thing here that's mentioned here is that it prevents harmful UV radiation from entering. Now, important to realize that if we didn't have an atmosphere, what we would have is, I suppose, all of the radiation from the sun reaching the planet and going straight down. So there's no way that life could exist under those conditions, because direct UV radiation can lead to high instances of cancer. Okay, and it's just not very suitable for life. Okay, so it protects us from those harmful UV rays. The next thing then is it insulates us from extreme temperatures. So you might realize that the planet is rotating, and that every 24 hours it has completed a full rotation. But during nighttime, guys, the Earth is faced away from the sun. It's actually faced towards space. So, because it is faced towards space, the temperature, if there was no atmosphere there, let's pretend for a second there was no atmosphere, the temperature, there would be nothing to stop the temperature from going down into very low negative numbers like minus 100 degrees Celsius. But because we have an atmosphere, it spreads the heat around the planet. So when one side is facing the planet or facing the sun, the heat from that area is passed down to the area that is facing into space. So therefore, we have kind of an average temperature overnight that's not very, very low, that would not support life. And I already mentioned the last one, the atmosphere burns up the celestial bodies like meteors and comets, so that they never harm us and never reach the surface. So I think another point I want to raise here, because in our solar system so far, we are the only planet on our in our solar system and galaxy where we know there are life. Okay, and there's something really unique about our solar system that has allowed that. So all of these conditions here are unique. There's oxygen, there's a thick atmosphere which kind of spreads out the heat, which insulates us. Um, we are, I suppose, far enough away from the asteroid belt that it's not a problem, but also because we have this planet here, and we actually believe this planet here could be essential, because Jupiter, being such a massive planet, tends to absorb in asteroids and other comets and celestial bodies, which, if they were going towards the Earth, could cause serious harm. So Jupiter is called the Hoover of our solar system, and by cleaning out and basically pulling in these celestial bodies into Jupiter, due to its high gravitational pull, it's actually protecting life on Earth. Okay, because then we don't have the asteroid collisions on Earth, we don't have the comet collisions or meteor collisions that would happen on Jupiter, which is the gravitational pull is causing a large amount of collisions on a regular basis. Right. I'm going to come back to this investigation tomorrow and we will explain what you'll be doing, but your homework will now be posted on Google Classroom.